Welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is the Triangle Exterior Angle Theorem. Let's get prepared. We're going to need a pencil with an eraser, some paper, of course, and calculator is optional, as well as a straight edge, because we will be drawing some triangles and some exterior angles. And if you want to draw straight lines with that, then use that straight angle or that straight edge or a ruler. Don't forget to pause the video from time to time to answer the practice questions, or rewind the video if you need to review anything before trying to answer the questions. All right, so I'm Miss G, and we're going to start today's lesson by doing some deep breathing exercises. We're going to breathe in our nose and hold it for 3 count, and then breathe out our mouth. We're going to do this 3 times to try to clear our thoughts and get our minds all fresh for the math learning today. So let's go ahead, breathe in, hold it for 1, 2, 3, breathe out. Breathe in, hold it for 1, 2, 3, breathe out. Okay, and the last breath, breathe in, hold it for 1, 2, 3, then breathe out. And if you need to take additional breaths along the way, feel free to pause the video and take some extra deep breaths just to clear your head and get all those distracting thoughts out of the way. Okay, so let's look at some of our vocabulary. Nature's great book is written in the language of mathematics. So Galileo Galilei, he knew about that, how wonderful mathematics is, and how the language of the universe is written in mathematics. And again, the more you work with mathematics, the more you start to realize that and see it everywhere. It is really a good way to understand how nature works all around us. Okay, so the theorem is a statement or a law in mathematics where we can prove it through logic and reason. One of the theorems we studied was the Triangle Sum Theorem, which states that all 3 angles in every triangle add up to 180 degrees. The Exterior Angle Theorem in triangles is what we're going to learn about today. Vertical angles is the angles that are across from each other on a crisscross, but also congruent to one another. Supplementary angles are 2 angles that add up to 180 degrees, or a straight line, also called a linear pair of angles. And then complementary angles are those 2 angles that add up to 90 degrees, or a right angle. Right triangles are triangles that have at least one 90-degree angle in it. And adjacent angles are those angles that are right next to each other. They share a side and a common vertex point. Exterior angles are those outside of the triangle or the parallel lines. And then interior angles are those inside the triangle or the parallel lines, or any shape really. It could be a square, exterior to the square, or interior inside the square, that kind of thing. Alternate interior angles, again, these are all formed from this parallel lines and transversal relationships. So if you haven't watched that video, definitely watch that one. So when parallel lines are cut by this transversal line, we get alternate interior angles, which are alternate sides of the transversal, but it's inside of the parallel lines. They're also congruent. Same side interior angles are those on the same side of the transversal, but inside the triangle, or the parallel lines, excuse me. And those are not congruent like the alternate interior angles and the alternate exterior angles are. Same side interior angles are supplementary, so they'll add up to 180. Alternate exterior angles are alternate of the transversal, or on opposite sides of the transversal, which is another way of saying alternate sides. And then exterior to the parallel lines. Same side exterior is also supplementary like the same side interior. And same side exterior means they're on the same side of the transversal, but exterior to the parallel lines. And then corresponding angles are those angle relationships that are in the relative same location on each intersection point of that parallel line and transversal. So if you cut it out and place it on top of the other intersection, The ones that are right on top of each other are going to be those corresponding angles, and corresponding angles are congruent. All right, lesson essential questions. The first one is define remote interior angles within a triangle. Number 2 is explain what is the Triangle Exterior Angle Theorem. And number 3 is explain how the exterior angle theorem can help you solve for a missing exterior angle. All right, so the triangle sum theorem states that, I hit 2 buttons there. A theorem is a statement or general rule in mathematics that has been proved through reason. A theorem can be expressed as a written statement, math symbol, or a formula. The triangle sum theorem states that all 3 interior angle measurements of any triangle must add up to 180 degrees. Here's an example. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So all 3 of these angles add up to 180. Another example for this triangle RST. In this case, we are missing an angle, so we can find that angle by adding all 3 angles up, making them equal to 180, and solving to get that missing angle. This is all review, by the way, right? Hopefully you've watched the triangle sum theorem before watching this one, and possibly, hopefully you've watched the supplementary and vertical angle video as well. Right triangles are triangles that have 190-degree angle inside. And when we use right triangles, we know that the other 2 angles that aren't 90 degrees have to add up to make 90 degrees, because 90 plus 90 is that 180 inside the triangle relationship. So if I were to say, if angle A was 60, what would angle B be? So I would say, okay, well, 60 plus what's going to give me a 90, and that's going to be 30. Okay, so 60 and 90, or 60 and 30 make a 90, and then added to this 90 is going to make that 180 for the total. Interior and exterior angles. As a review, the word interior means being inside of something. So when we have a triangle, the interior angles are the angles inside of the triangle, and the exterior angles are the angles outside the triangle, and they share a side with the interior triangle. So when we're talking about the exterior angle theorem in a moment, we're talking about these 2 kinds of exterior angles, not the vertical angle, okay? The vertical angle is on the crisscross here, and notice that vertical angle does not share a side with that triangle, but angle 4 and angle 5 does. So these 2 exterior angles are what we're talking about when we're talking about exterior angle theorem. Supplementary angles are linear pairs. A supplementary angle relationship or linear pair is when the measure of 2 angles add up to 180 degrees. The angles may be adjacent, side by side, or not adjacent, not right beside each other. The straight angle is formed when supplementary angles are placed adjacent to one another, creating a straight line or a 180-degree straight angle. Here's just some examples of some that are adjacent to one another, supplementary angle pairs, and ones that are not adjacent to one another. So again, you can be supplementary and adjacent, or you could be supplementary and not adjacent at the same time. Okay, here's our triangle exterior angle theorem. So let's talk about this. The triangle exterior angle theorem states that any exterior angle of a triangle is always equal to the sum of the 2 remote interior angles located inside of the triangle and on opposite side from the exterior angle. So here in our first example, we have the exterior angle D, and we know because of this theorem that this angle D has to equal the sum of these 2 remote interior angles, okay, A and B. Now, the reason this works, I'm going to show you kind of how this works, okay? And here's another example, and I'm going to show you on this example. Let me change to my pen here. Okay, so let's say that this exterior angle here is 130 degrees. Okay. Now, because this is 130, I know that 3 here, this angle 3, because it forms a line with this 4 here, That's a supplementary pair. So if this is 130, then this angle 3 must be 50, because it has to add, ooh, my mouse has stopped working for some reason. It has to add together to make the 180 line, right? That's a 50. It just doesn't look like a 50. Okay. So 50 plus 130 makes this 180 line. So what they're saying is that these two angles here also have to equal whatever this angle outside is, because we know that those two added to this 50 also must equal 180, because all the angles inside of the triangle have to also equal 180. So if I were to add these two together, I'm still going to get this 130, because 130 plus 50 is 180 inside the triangle, and 50 plus 130 makes this line outside the triangle and inside, like partially outside, partially inside, that whole thing there. Okay. Now, what is sometimes difficult for students to remember is which angles are the remote interior angles. Okay, so if I was showing a student the remote interior angles, I would say it this way. The one that's outside, the exterior angle, there's only one angle that's right next to it or adjacent, and that's this one. Okay, these two are not adjacent to the exterior angle. So the two angles that are not adjacent are the remote interior angles. Okay, so the remote means far away. So basically they're far away from this exterior angle. The one that's right next to the angle, this one here, is going to be adjacent to it. So it's not going to be remote. It's going to be real close, right? Whereas these two are the remote. Again, these two remote angles here, let me clear this up. Ooh. I don't know why my computer's lagging today. Okie dokie. Let's erase this because I had a lot of writing on here. There we go. Okay, so these two angles inside here, okay, are going to add up to equal this one, okay? But these two are remote. Notice they're not right next to the exterior angle. Angle 3 is right next to this angle 4 outside. So again, if you're trying to figure out which two of the 3 triangle angles to add together to equal that exterior angle, pick the two that are farthest away from that exterior angle. Okay, let's try some of these. So using the Triangle Exterior Angle Theorem, let's try to solve for some missing exterior angles. So here's our first one. We have angle X, which is outside. Now 63 and 63 are the two remote interior angles, right? So we're going to add those together, and whatever they are is going to be equal to that exterior angle X. So 63 plus 63. Okay. The second one is trying to find this angle Y. And again, we've got two remote interior angles here, 90 and 57. So we're going to add those together. We're going to end up getting 147. So when you know this theorem, it makes solving for outside angles or exterior angles a little bit easier than adding all 3 angles together and getting that solution for that and then subtracting it from 180 like we did when we were solving those triangle sum theorem problems. This is a lot easier if you know that exterior angle theorem. Here's another one, angle Z, and we're trying to find, oh, that should say find the angle Z, not angle 1. Let me fix that. All right, so now we have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, or excuse me, equals the measure of angle 3, which is our outside angle here. And that ends up being 34 plus 34 because these are the remote interior angles. Notice they're not right beside this exterior angle. They're far away, and that's how we got our 68 for angle Z. And here's the one for the measure of angle A, which is out here. We have 2 remote interior angles. It's not this third one that's next to the A. It's these remote ones. So 41 plus 90 is going to get us 131, which is this angle A here. Over here, we have a more complex problem where we know that the 2 remote interior angles on this side is going to equal the 146 on the outside, the exterior angle. So we would set it up. by finding, they're asking us to find y this time, not the entire angle. So after you find y, you could substitute it in to find either one of these angles, but we're just going to find y for now. So we know that the two angles that are remote and interior added together must equal this third one out here. That's the exterior angle. 5y plus 3 plus 4y plus 8. These are the two angles we have here. Added together, we're going to combine our 5y and our 4y to get this 9y. 3 plus 8 is 11. Solve that two-step equation by subtracting 11 from both sides and then dividing by 9 on both sides. Y is going to be 15. The second example, again, we have two remote interior angles, and those two added together must equal the 116. So to find y, you would add the two together. 4y plus 7y plus 6 equals 116. And then combine your like terms. 4y and 7y make 11y. And then subtract your 6 from both sides to solve that two-step equation. Then divide by 11 on both sides to undo that multiplication. And y is going to be equal to 10. And again, if I wanted to find out what this angle was, for instance, I would just do 4 times the 10, and that would be 40, and so forth. Okay, let's try and grow a blossom. Use the Triangle Exterior Angle Theorem to find the measure of angle x for both triangles. So pause. 1, 2, 3. Okay, for our first example, we have the measure of angle 1 plus the measure of angle 2 equals the third out here exterior angle z, or x, excuse me. 67 plus 67, that's going to be 134 degrees. The second example, the measure of angle 1 plus the measure of angle 2 equals this outside measure of angle 3 exterior angle. 90 plus 67 is going to be 157 degrees. Try to grow a second blossom. Use the Triangle Exterior Angle Theorem to find the value of both x for both, the value of x for both triangles. Pause. Okay, so we're going to add the negative x, the negative 8x plus 6. We're going to add that to the 5x plus 4, and all of that's going to be equal to this 2x out here on the exterior. Combine your like terms. So negative 8x plus this positive 5x gives us a negative 3x. 6 plus the 4 gives us the 10. Now we've got a two-step equation, or almost a two-step equation. We've got a variable on both sides here. So I'm going to move my 10 over to the right by subtracting 10 from both sides. Then I'm going to move this 2x to the left by subtracting 2x here and canceling that out. And then subtracting it over here. And negative 3 minus negative 2 gives us negative 5x. Okay? Negative 5x equaling negative 10 over here because this canceled out. Let me turn my... Okay, so this canceled out. And this is going to cancel out. Negative 5 divided by negative 5. And negative 5 divided by negative 10 divided by negative 5 gives us this x equals 2. For the second example, we have the measure of angle 1 plus the measure of angle 2 equals this outside measure of angle 3. So 90 here plus this x minus 14 has to equal the 5x. Okay, combine your like terms. So the 90 here is going to be combined with this minus 14. That's going to give us a 76. And then I've got, again, variables on both sides. We know to cancel one of those out. I'm just going to cancel the one on the left this time. That's going to give me 4x on the right. Then divide by 4 to get rid of that coefficient. And x is going to end up being 19. So solving equations is very important when you're dealing with geometry. That's why I tell my students often that it's very good to learn geometry while you're learning algebra and not to just learn one or the other, because you kind of need both to work with both. Use the Triangle Exterior Angle Theorem to find the measure of angle 3x this time. Pause. 1, 2, 3. All right, the measure of angle 1 plus the measure of angle 2 this time equals the measure of angle 3, which is this 3x exterior angle. 4x plus 16 was our first angle. And then we're going to add it to the negative 9x minus 4. Now I put a parentheses around this negative 9x because I don't like putting a plus right next to a negative number. You don't have to do that, but that's how you see it often in math, and that's just what I like to do. So if you just put a plus and then minus 9x next to it, that's okay. But just know that often you'll see it with parentheses around it just to keep that plus separate from your negative number there. Combine those like terms. The 4x can be combined with a negative 9x, which gives us negative 5x. And then 16 here plus this negative 4 or minus 4. Ooh, there goes my mouse again. I think I need a new one. It's going to give us a 12. We have variables on both sides again, but I'm going to move this constant over to the other side, and that gives me 3x minus 12 over here now. And this time I'm going to move my 3x. So if I move 3x from this side over here, I get a negative 8x. And then when I divide by 8 to cancel that out, here I've got a fraction that will not give me a whole number, okay? So when that happens, I'm going to get a decimal. Now you can write it as a decimal answer. In this case, I just simplified the fraction because I know a negative divided by a negative gives me a positive answer. So I went ahead and simplified this by dividing by 4 here and here on the numerator and the denominator. And I just reduced that down to 3/2, okay? Again, if I used my calculator and typed in negative 12 divided by 8, I'm going to get 1.5, okay? So if you wrote 1.5 here instead of 3/2, that also works. I'll write 1.5 here so you can see that you can do it in decimal form or fraction form. And so they're both right, whichever one you decide to use. I use fractions because I know a lot of my students struggle with fractions, and I feel like they need to see more fractions being used in problems like this. So what I did here is after I found out what x is, since we need to know the measure of the angle 3x, that means we need to multiply 3 times our x. So multiplying a fraction times a whole number, remember we turn that whole number into a fraction first by placing it over 1. And 3 times 3 is 9. And then 1 times 2 is 2. Okay, that's where I got the 9/2. Now what I did was convert that into a mixed number by dividing. Remember, 9 divided by 2 is 4 with a 1 remainder. That 1 remainder goes over that existing denominator. And we end up with 4.5 degrees, or in decimal form, 4.5 degrees. Okay, here's the last blossom. Use the Triangle Exterior Angle Theorem to find the measure of angle 6z minus 15. Pause. All right, so here we have the measure of angle 1 and 2, which are these interior, remote interior angles, added together equaling this exterior angle on the outside, 6z minus 15, which is the one we're trying to find. We need to solve for z first, so we're going to combine our like terms, the 2z and the 3z together is going to get me this 5z, and then the negative 14 or minus 14, and the positive 2 gives me negative 12 or minus 12. Okay, the right side hasn't changed yet, so it's still 6z minus 15. Okay, I'm going to move that constant over. I'm going to get rid of that 12 on the left side, move it over to the right, and negative 15 plus this 12. I don't know why I didn't put a plus there, but it should go there. It's going to give us this minus 3 or negative 3. Okay, and this canceled out to a 0. Now I need my variable to be on the same side of the equation as the other variable. So I'm just going to get rid of this one on the right by subtracting 6z to cancel that out. And when I subtract 6z from this 5z, I end up with negative 1z. Okay, I'm almost there because I know this side is negative 3, but I don't know what this side is. So I'm going to divide by negative 1 on both sides. That's going to cancel that coefficient out. And a negative divided by a negative gives me this positive 3. That's what z is equal to. So now I'm going to plug that in, substitute it in here. 6 times 3, 6 times z minus 15. So that's going to give me 18 minus 15, which is 3 degrees. And again, this is one of those situations where Miss G made up numbers in her head to come up with this problem. And 3 degrees is not, like, if I were really to guess the measure of this angle here, it's not going to be like a 3 degree angle is going to look more like, it's going to be really tiny. It's not going to be big like that. But, you know, these are just numbers I made up in my head, so they don't make a lot of sense. But if you notice that that was 3 degrees and that angle does not look like a 3-degree angle, then kudos to you, because that's really not a 3-degree angle. I just, again, just made up numbers and they didn't quite work out for reality there. But we did solve the problem correctly, so that's good. All right, so now let's solve the first answer the essential question. Go ahead and pause and try to answer define remote interior angles within a triangle. What are those? What are remote interior angles? Okay, the remote interior angles of a triangle are the two angles that are on the opposite side of the triangle relative to the exterior angle that does not share a side with them. The second essential question is explain what is the Triangle Exterior Angle Theorem. Pause. The answer, the Triangle Exterior Angle Theorem states that any exterior angle of a triangle is always equal to the sum of the two remote interior angles. Now, if you stopped right there and just said, well, the sum of the two remote interior angles is equal to the outside or exterior angle, that's a great explanation. I went further and said the two remote interior angles are located inside the triangle and on the opposite side from the exterior angle. That's just really for you guys so that you can, you know, get another idea of what those two remote interior angles are. Okay, so if you stopped there and didn't go on with the explanation, that's okay. All right, the third essential question, explain how the exterior angle theorem can help you solve for a missing exterior angle. Pause. All right, so we're going to set up an equation by adding the two remote interior angles together and making them equal to the exterior angle. Solve for the variable and then substitute the variable or the value of the variable back into the angle expression if necessary. All right, we're going to go over our vocabulary. Yay, we got a zebra to help us out, and he's in the blossoms and looking all nice and cool. All right, a theorem is our math statement or law that's proven to be true through logic. And the two theorems we learned, the first one was triangle sum theorem. And of course, that's the one where all three angles of any triangle add up to 180 degrees. The one for today's video was the triangle exterior angle theorem. And the triangle exterior angle theorem just states that two remote interior angles added together equal the exterior angle. Vertical angles are those two angles opposite of a crisscross that do not share side, but they do share a vertex point and they are congruent to one another. The supplementary angles are two angles that add up to 180 degrees, also called a linear pair of angles. And then complementary angles are angles that add up to 90 degrees or a right angle. A right triangle is a triangle that has one 90-degree angle in it. And adjacent angles are angles that are side by side, sharing a side, and also share a common vertex point, just like neighbors sharing a fence. And then the exterior angles are angles that are outside of a triangle or parallel lines. And then inside the triangle or parallel lines, or any shape really, is the interior angles as well. So exterior is outside, interior is inside. And again, these last 1, 2, 3, 4, 5 angle relationships are caused oftentimes by the parallel lines and transversal relationships. So I've got, you know, the two lines with the transversal going through, and alternate interior angles would be inside the parallel lines here and here, but on opposite sides of that transversal. Okay, alternate sides of transversal inside the parallel lines, and they're congruent. Okay, alternate exterior angles, they're going to be outside the parallel lines. So let me change colors here. Oops. All right, so let me change this one. Okay, so outside, so this one and this one would be two that are exterior, but also on opposite sides or alternate sides of that transversal. And they're also congruent to one another. Same side interior angles would be like these green ones I'm about to draw. They're on the same side of the transversal. Okay, And it's just like this red one. I'm just going to color over it with green now. So these two are inside, same side of the transversal, but inside the parallel lines. And then same side exterior angles. I'll make those purple for us. And there's going to be outside the triangle. So we could say here and here over this blue one. And those are outside the triangle. Oh, I didn't make that one opposite or alternates. Let me erase that. Ooh, I erased the whole. Well, that's not good. All right, so if I had one here and then one here, that would be exterior, but also on the same side. Let me erase the purple here because we don't want, I keep erasing our lines here. Well, I am just not good with this today. There we go. All right, so here and here. And again, these same side angle relationships are going to be a supplementary pair. It's not going to be congruent like those alternate angle relationships are. Okay. And then those corresponding angle relationships are those, and it's easier for me to draw it like this, where you have a different shape. Like my mouse would work better today. Okay, so here we got our parallel lines, our transversal. And so corresponding angles, like if I had a circle representing this angle, the corresponding angle down here would be this one. Okay, if I had a triangle representing this angle, corresponding angle down here would be this one. And then I got an X for this one, X for this one. And then I'll just put like a, oops, and I'll change colors. And we'll make this one a little red dot, and it's corresponding with this red dot. Okay. So again, if I were to take all of this little intersection here, pick it up, cut it out, and drop it right on top of this intersection here, that circle is going to be corresponding with that circle. That triangle is going to be corresponding with that triangle. And that red dot is going to be corresponding with this red dot. And then the X is going to be corresponding with the X. And they're also congruent. Okay. And then parallel lines and transversals, again, are the two straight lines that never cross, or parallel lines. And the transversal is that line that we draw going through them. Okay, great work. A math blossom bouquet have opened up in your mind today. So to further improve your math language skills, remember to practice by doing your assignments at school for math. And then if you would need additional practice, just ask your teacher. I'm sure they wouldn't mind giving you some extra practice problems if you need it. Study at least 10 minutes a day. Ask for help if you need it. And then learn from your mistakes if you make any mistakes, which we all do. And don't beat yourself up over it. But always try and do your best when you're working with math or any school subject. So I'm Miss G, and thank you for watching this Math Blossoms video. And this may wrap up my series on angle relationships and triangles. So if you've watched the parallel lines and transversal video and this one, and the triangle sum video, and the ones on supplementary, vertical, complementary, and adjacent, I think that's all the ones from the series that you'll need for this level of math. So again, hopefully this was informative for you. And as always, it's time for me to say it was lovely teaching you math today. Bye.